Hey everyone, welcome to my YouTube channel, The Tutor named Fran. I'm Fran and this video is about... Don't forget at the end of the video to like, comment, share, and subscribe. So let's get started. So what is a limit? You're probably familiar with the limit as x goes to c of f of x equals L. You've probably seen this notation before. Now, what does the c indicate in this case? The c is the x value that we're heading towards, okay? It's that horizontal value that we're looking at. And what we want to see is that as we get closer and closer to this value, where does our function, our f of x, go to? Okay, and remember when we refer to our function, the function value, we're always referring to the y value. So let's consider this example of the limit as x goes to 5 of 3x squared. Well, in order to solve this, we're going to consider an approximation, okay, because we're not at 5, okay? We want to know the limit as we're getting closer and closer to 5. So let's think of some values that are really close to 5. Okay, maybe you think of 4.9, 5.1. So let's write these. So maybe 4.9. You could say 4.99, right? 4.999, okay? We can consider 5.1. Right, we can consider 5.01, 5.001, right? All these values are pretty close to 5. So since we don't want to look at exactly at 5, we want to know what's happening around it, these are some good values to consider. So what we're going to do with these values is we're going to say, well, when x is equal to these values, what is y equal to? And remember, to find that, we could just substitute these values into our function, which is 3x squared. So let's organize these values. So we have 4.9, 4.99, 4.99. We're going to skip 5, right, because we're just worried about what's happening around it. So putting these in order, the next one is 5.001, 5.01, and then 5.1. And now what we want to find is what is y at these values. So we could do a chart. So when y is equal to 3x squared, okay, when x is equal to 4.9, what is y? Well, we can just plug that into our function and find our corresponding output. So if you put this in your calculator or use Wolfram Alpha, however you choose, you will end up with 72.03. For 4.99, you're going to get 74.7. For 4.999, you're going to get 74.97. For 5.001, you're going to get 75.03. For 5.01, you're going to get 75.3. And for 5.1, you're going to get 78.03. So remember, 5 lies somewhere here in between 4.999 and 5.001. So as we're approaching in this direction, right, getting closer and closer to 5, what number are our y values approaching? Well, it looks like we're going to 75, right? That would be reasonable because we stop at 74.97. We could do a check you could consider what happens at 4.9999, okay? So you could check that one on your own. You'll see that you get 74.997. Okay, so again, you're getting closer to that 75, but not quite there. And same thing happens as you're coming from this side. You're getting closer and closer to that 75 value, right? You start with 78.3, then 75.3, then 75.03. You could do the same thing here where you look at 5.0001, okay? And you're actually going to get 75.003. So you can see that we're kind of approaching this value of 75, right? So our approximation here is that the limit as x approaches 5 of 3x squared is going to be equal to 75. So we want to write that as our answer. So the limit as x approaches 5 of 3x squared is equal to 75. And again, this is by approximation. And you might say, well, it looks like all we had to do was figure out y when x was equal to 5, and we can get our 75. And that's true in this case, but it's not always true. Okay, and there's a reason why it works in this limit here. So we're going to look at that next. Consider this. Here we have a function, and we know this is a function, right? It passes the vertical line test. And here, if we look at this value, okay, as x approaches -3, so as we travel in this direction, let's say to -3, and as we travel in this direction to -3, it looks like we're approaching the value of +4, right? But the true function value doesn't lie there. The true function value lies at 6. And sometimes this can happen. So sometimes we're able to take the true function value as the limit, like we did in the last example, but sometimes we cannot. So it's important that we look at the graph and visually see where these values actually lie. Now, we're kind of looking at getting closer and closer to -3 from like this side and that side. So those are actually called left and right hand limits. All right, so we have the left hand limit and then we have our right hand limit. Each one has its own notation. They're very similar. So the left-hand limit, that's the limit coming from the left, so going in that direction, we write as the limit as x goes to c from the negative side of f of x equals L. And the right-hand limit, we write as the limit as x goes to c from the positive side of f of x equals L. So let's consider this problem that we have here. As we go from the left-hand side, right, as we approach -3 from the left-hand side, we can see that we're approaching 4, okay? Although the true value is 6, that's not the value that we're approaching, because remember, we're only using the numbers as we get closer and closer to -3, right? So -3.1, right? -3.001. We're looking at all those numbers that are kind of like right here. Okay, all these numbers here. As we're getting closer and closer to -3, okay, this point, we actually get a value of 4. So let's write that. So the limit for this example as x goes to -3 from the left-hand side, okay, we're just going to say this is f of x because this is some function, equals 4. And now let's look at it from the right-hand side. So as we approach from the right-hand side, okay, so maybe like negative 2.9, negative 2.99999, right? If we're looking at those values, we're still approaching the same y value of positive 4 here. So the limit as x goes to negative 3 from the positive side is also positive 4. Now there's another interesting part to this function, and that's over here. Okay, that's at this value right there, at positive 1, at x equals positive 1. The limit as x goes to 1 from the positive side of f of x, and we look at the limit as x goes to 1 from the negative side of f of x. So we have from positive 1, we're approaching from the left-hand side. Well, it looks like the function value is at 2, at positive 2. Right? So from the left-hand side, our limit is actually approaching 2, but from the right-hand side, right, so as we go in this direction here, well, that's actually following this y value, and that's negative 2. Right? So negative 2. Well, what we get is that if the limit as x approaches c from the left of f of x is not equal to the limit as x approaches c from the positive side of f of x, then the limit as x approaches c of f of x does not exist, DNE. So for the orange example, we have that the overall limit, the limit as x goes to negative 3 of f of x is equal to 4. Now for the purple example, we have that the limit as x goes to 1 of f of x does not exist, DNE. So remember, if the left-hand limit does not equal the right-hand limit, then the overall limit does not exist. If you enjoyed this video, make sure you give it a thumbs up, and remember, like, comment, share, and subscribe.